Here it says to solve for the magnitude and direction of the resultant. So we're going to be solving for the length of the resultant and also for the direction here. Now the first thing to do would be to draw our resultant. Okay, so we know that the resultant always goes from start to finish. And to also anticipate a few things, so we're going to make a few notes over here. We know that our resultant is in the second quadrant, so we expect a direction between 90 degrees and 180 degrees. We also know that we had to go to the left and then up, so we should have a negative x and a positive y. Okay, so in order to solve for the length of this resultant, we need to know the x and y components of it. So the x component, we'll make it red, and it's the total distance that we have to go to the left in order to make our resultant here. We get this total x by adding together the different x's from our three vectors. So notice that this vector went over to the left, so it should have a negative x displacement. This one went over to the right, so it should have a positive x displacement. And this one went over to the left as well. So it should have a negative displacement. Alright, and then we have our y displacement. We want to know how far up did we go here. Redraw that line so it's a little bit cleaner. Okay. When we do this, we have a nice right triangle, and we can figure out, using our x and our y in the Pythagorean theorem, what our r is. So if we can find the y components of each of these vectors, notice that the first two are positive because they move upward, and the last one is negative because it moves downward. Then we can figure out the y components of our resultant. Alright, so let's try x first. Here you'll notice that we have nice clean lines and that we are actually able to make a little right triangle here, where the hypotenuse is 34 meters per second. And the direction is 100 degrees. Now, I know that the interior angle here is different, but we actually want to use the measurement from 0, from the positive x-axis, which is 100 degrees. Notice that we passed 90 and went just a little bit further. So our x1 will equal our hypotenuse, which is 34 meters per second, cosine our theta. Alright, so notice whenever we use a direction of 100, we should be able to get a negative x because we moved to the left and a positive y. So 34 cosine 100, and we get negative 5.9, which is what we anticipated since we had a horizontal displacement to the left. Alright, x2, how far this second vector went over, right here, or right here, x2, will be the hypotenuse times the measurement from 0 right here. So we have a hypotenuse of 28 meters per second, and then it has a measurement of 65 degrees from 0. So this will equal 28 cosine 65. So we plug this in and get 11.8 meters per second. Our final x is how far to the left this last vector went. Now the hypotenuse here is 65 meters per second. And we use cosine, and now we need to figure out what is our direction. Now, the problem tells us that the angle right here is 35 degrees, but we want the measurement from 0 degrees. We know that this line right here is 180 and that we went 35 further. So we're going to take 180 and add 35, and our direction here is actually 215 degrees. This way, when we plug in our total direction, given the hypotenuse we have, we should be able to get a pretty large negative number because we know it went to the left a pretty good amount. And there we have it. So we have a negative 53.2 meter per second x component. Alright, now we can do the same thing but with our y's. The only thing that's going to change in this equation is that the cosine will now be sine. So y1 will equal 34 sine 100 to let us know how far up this y component went to get the vector, and then y2 will equal our hypotenuse 28 meters per second sine the angle, which was 65, to find out exactly how far up this second vector went, and then we can figure out how far down our third vector went, so our y should be negative, by doing 65 sine 215, which is the total measurement, not just the angle we were given right in here. So we're going to plug those three in to find our y displacement. So 34 sine 100, and we get 33.5 meters per second. And then 28 sine 65, and we get 25.4 meters per second. And this last one will be 65 sine 215, and we should get a negative number since we went down. We get negative 37.3. meters per second. So now we have all of the x components. So we know how far over this vector went to the left, how far over this one went to the right, and then this large one over to the left. And when we add those all together, it will give us how far over to the left our resultant went. So we can add negative 5.9, 11.8, and negative 53.2 to get our x total. And we get negative 47.3 meters per second. So we know that our x here is negative 47.3. We know that our y is a combination of these three. Right, notice that the first two went up while the last one went down, which is why we have two positives and then a negative. So 33.5 plus 25.4 plus negative 37.3, and we get 21.6, which makes sense because our y was positive. Meters per second. So we know we went up here 21.6 meters per second. Alright, now we can find the length of our resultant because we know the total x from the three vectors and the total y from the three vectors. So what we're going to do is use the Pythagorean theorem. So 21.6 squared plus, and now a negative number squared is going to be a positive number, so you can either choose to just skip using the negative, or if you're going to use the negative to keep your information correct, you need to put your information inside parentheses. Let's try that again. I think the squared should be on the outside. There we go. We can store our answer and take the square root of it so that we don't have to type it all over again. And we get 52. So we know we have a resulting velocity of 52 meters per second. Now to find the direction, we would do the inverse tangent of our y over our y being 21.6 and our x being negative 47.3. Remember to include your negative components, and we get negative 24.5. So if we think about this really fast and think about our resultant and where it is, negative 24.5 is really somewhere over here. So we know that we have to do the tangent quadrant check, and we know since we're in the second quadrant, we should be somewhere between 90 and 180. This is not between 90 and 180. This is actually a whole half circle behind it. So we need to take this number and add 180 degrees to it. And we get 155.5. degrees, which is somewhere between 90 degrees and 180 degrees. So we've now found our resulting magnitude and direction for our resultant.